Hey guys, it's simple as that, Simpstuck. Today we're doing a coordinate proof review, and it's the last day of February. But before we do coordinate proofs, I want to touch base a little about something that we did very recently, but I haven't made a video about it yet, and it's proofs with literal coordinates. Now what does this mean? You'll see what I mean soon. It's just basically coordinates that aren't well defined. They're just variables. So, for example, I'm trying to think of a hard one to do here. So let's say this is number 4 on this sheet that the overseer has given us. And this is quadrilateral JAKE has coordinates J, which is 0, 3A, A coordinates 3A and 3A, K, which has coordinates 4A and 0, and we have E with negative A and 0. As you can see, they're variable coordinates. And they're telling us right here, prove by coordinate geometry that quadrilateral JAKE is an isosceles trapezoid. Prove it is an isosceles trapezoid. Prove it is an isosceles trapezoid. Well, what do we know about isosceles trapezoids? Well, first of all, a trapezoid has only one pair of parallel sides, right? Only one pair of parallel sides, and those are the bases. The bases have parallel sides, and isosceles means that the trapezoid's legs are congruent, and they want us to prove using coordinate geometry with all these variables that it is an isosceles trapezoid. Okay, well, if we want to prove parallel sides, that's going to involve doing a bit of slope, and I can tell you right now that we're going to have to find the slope of JA and KE, because when you put it in perspective, it's going to look kind of like that is the trapezoid that we're making. So we need to prove that JA is parallel to KE. So let's go ahead and do that. We know that our slope formula is a y1 minus y2 over x1 minus x2. So let's find JA first. 3a minus 3a, y1 minus y2 over x1 minus x2. Okay, you just treat the variables like they were ordinary numbers. So the 3a minus 3a cancels out obviously to be 0, and the 0 minus 3a becomes negative 3a, but it doesn't really matter because it's 0 divided by something, so the answer is just going to be 0 as the slope here. Now let's try the same thing with K. So this is JA's slope over here. So now let's try KE, and that's going to be 0 minus 0, y1 minus y2 over x1 minus x2. It's a plus because there's a double negative in what we're doing here. 4a minus negative a. Doesn't matter, 0 on the top, we already know it's going to be 0, isn't it? So this is also going to be 0, and that's KE slope. So we do see that both of these slopes are the same, so that must mean that JA and KE are indeed parallel. Now if we want to prove that this is not a parallelogram but indeed a trapezoid, we need to prove that these are not parallel. We need to prove that JE and AK aren't parallel. So let's just do that real quick. So let's do JE. So for JE we have 3a minus 0 over 0 minus, well, 0 plus a. So that's going to be 3a over A, or just 3. For AK, it's going to be 3A minus 0 over 3A minus 4A. It's going to be 3A minus A. A's cancel out, so it's going to be negative 3. So, as you can see, these slopes are not the same. So, therefore, these are not parallel. So, we know for sure that JAKE is a trapezoid, because it only has one pair of parallel sides. Kind of cool when you're using literal coordinates. So now that we know that it's a trapezoid, we now need to know that because we've checked off this portion, we need to prove this portion, the legs are congruent. So we need to find the length of JE and AK right here. And we need them to be congruent for us in order to prove that it's an isosceles. And what do you use for that? Distance. For literal coordinates, distance can be kind of a pain in the butt, but it's not too bad. So first let's do the JE here. So big square root of 0 plus A squared, right? Because it's 0 minus negative A. And so that's just a double negative, so it just becomes a positive, so it's 0 plus A squared plus y1 minus y2, so 3A minus 0 squared. Let's do some simplifications. This is A squared, and this becomes 3A squared, right there. And this becomes 4A squared. So, taking the square root, we're going to have 2A. And that's going to be our distance, 2A here. Now for AK, we're going to do a similar thing. We're just going to do the same thing. Square root. We're going to have 3A minus 4A squared plus 3A minus 0 squared. This is going to be negative A squared plus 3A squared. This is going to be A squared plus 3A squared. So this just becomes 4A squared. Combine the like terms, and when we take the square root of all this, it's 2A. As you can see, we've gotten 2A for both our answers. They are equal, and so we can say that JE is indeed congruent to AK, and therefore wrote it wrong. Let me undo that. Therefore Jake is an isosceles trapezoid. So it's a bit more technical when you use literal coordinates, but basically it's the same thing. And now let's get into our actual coordinate proof review. So basically this whole thing is just applying formulas such as midpoint or distance or slope, stuff like that, so that we can make therefore statements and prove that things are equal to each other through mathematic rigor. So first, I talked about the hierarchy in the last video and how things always start with the parallelogram. Technically it's the quadrilateral, but we assume that a quadrilateral is kind of a given. So if we want to prove that a quadrilateral is a parallelogram, we can go 4 routes. The first route is to prove that both pairs of opposite sides of a parallelogram are equal. So prove both pairs of opposite sides are parallel, not equal, sorry. And to do that, you would find the slope. The second way you can do it, you could say that you should prove both pairs of opposite sides are congruent and not parallel. You can do this instead, although this is pretty technical. I wouldn't go this way. But anyways, you would use the distance formula for this. Only do it when absolutely necessary. The third way you could do it is prove one pair of opposite sides is congruent and parallel. And to do this, you do a combination of the two, slope and distance, to the same coordinates. And lastly, this is the easiest way to prove something's a parallelogram. I usually like this way. You have to prove that the diagonals bisect each other. And to do this, just very simple, find the midpoint of just 2 diagonals. And up here I'm going to have all the formulas here. So for the slope, you have m, which is slope, it equals x. 1 minus x, oh actually not x, oopsies, I meant y, just kidding. That's a crucial mistake. It's y1 minus y2 over x1 minus x2. That is always going to be your slope. Your midpoint is the average of x over the average of y, so it's going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. And your distance formula is kind of an abridged Pythagorean theorem. So it's going to be big square root of x1 minus x2 squared plus y1 minus y2 squared. Had to squeeze that one in there. Hopefully you can read all that. So those are the formulas. So this is the parallelogram thing. You prove both pairs of opposite sides are parallel. You use slope for that. Or you can prove both pairs of opposite sides are congruent. That is the most work that you could possibly do, and that's a distance. Or you could prove one pair of opposite sides are congruent and parallel, slope and distance. Or you can prove that the diagonals bisect each other, and that involves a midpoint. Now you can go 2 ways here. You can branch off into a proving something is a rhombus, or you could branch off into proving something's a rectangle. And I'm going to do both. Let's start with the rectangle first though. Okay, for rectangles, we could either go 3 ways here. So let's write down 3 ways. The first way is you have to first prove it's a parallelogram with, and you only need to prove one right angle after that. To do this, you require finding the slope of 2 consecutive sides and finding that they're negative reciprocals. So, negative recip. That's my shorthand for writing negative reciprocals, by the way. Sometimes I don't even write sip, I just write negative RE. The second way is to prove you don't have to go you don't have to prove that it's a parallelogram, but you do need to find the slope of all 4 sides. Find that it's equiangular And if we're talking about quadrilaterals, that means that all right angles. And this also requires slope. And again, negative reciprocals required. And the last way is to, again, prove it's a parallelogram, but it has congruent diagonals. You can do slope or whatever. And then you have to do a distance to prove the diagonals are congruent. So that's pretty much it for rectangles. And now for rhombuses, which is the other path you can take. This is also kind of the same thing here, but it's a bit different. The first one, you have to prove it's a parallelogram, blah blah blah, but you have to prove that it has two consecutive sides congruent, and this is distance. The second way you could do it, prove it's equilateral. Very similar to a rectangle's ways of proving it's a rectangle. And for this you use distance. And the third way, you have to prove it's a parallelogram, blah blah blah. And this is my favorite, with diagonals perpendicular. This is going to require slope as well as negative reciprocal slopes. And both of these will combine to form the proofs for a square. Square is kind of complicated because you have to go through the entire hierarchy bureaucracy of quadrilaterals to even get to a square. So the first way, you have to prove it's a parallelogram. You have to prove it's a parallelogram plus a rectangle plus two consecutive sides, which is kind of a pain to get through the whole thing. I remember I did a video on that, and that took quite a while. And you have to find the distance of these two consecutive sides. Of course, the rectangle is negative reciprocal, and parallelogram, you use whatever you want. The second way, you have to prove it's a parallelogram plus rhombus plus one right angle, which is just kind of like reversing what we're doing here. So you have to probably use slope here and also use slope here. And this is both negative reciprocal required here. And that's pretty much it for a square. For a trapezoid, let me just do it real quick. I already did it in this video. For a trapezoid, you gotta prove it only has one pair of parallel sides, which are the bases. And for that, you gotta use slope, and that's the same slope. And if it's an isosceles, if you want to find it's an isosceles trapezoid, legs have to be congruent, and that's distance. So hopefully all of that helped you to make a internal map in your head to try and figure out what you need to do, what formulas you need to come up with in order to prove all of these shapes are what they really are on paper. And no doubt you probably have to watch this video over once or twice again, and that's completely fine. That's the good thing about video, aside from the classroom, In a classroom, you don't get a repeat after class is over. But here, this video is going to be up basically forever, so you can just rewind, replay, and watch it again and again until you've learned the material. So, thanks for watching.